All right. What we ended up last time is we started off talking about quadratic equations and functions and zeros. We looked at the zero product principle. Is when you have two terms and they equal zero, then either A is zero, B is zero, or they're both zero. The first method we have for solving quadratic equations was factoring. We had two conditions here. Quadratic equations have this form. So factoring quadratic equations, if they're binary and there's two terms. If you have two terms, then both terms can have x's. It'll look like this: ax squared plus bx equals 0. To solve this equation, we factored out what was common in both of these terms was an x. We ended up with ax plus b in parentheses equals 0. We have two terms. This is the a, as we have up here, a times b, a, b. So we set both of these equations equal to 0. Because this times this equals 0, so one or both is 0. And solve for x. There's our first answer. The second answer is negative b over a. There's opposite sign of what's inside the parentheses, opposite sign divided by a. So that was the first case. The second case was only one term has an x. This one looked like this. The term that has an x has to be the squared, because if it's not the squared term, then it's not quadratic. It has to be quadratic. Now, to solve this one, we had only one term that has x. We had to isolate the x. So we have to subtract by c first, both sides, and then divide by a. So we have x squared equals negative c over a. And here we use the square root method. Since we're trying to get x by itself, we have to get rid of the square. So we square root both sides. And we have to put plus or minus in front of that square root on the other side, on the solution side. That's the important part. That's where we get our two solutions, because we're supposed to have two solutions. So for example, if we had x squared equals 4, and if we square root both sides, we get the square root and the square cancel. So x equals plus or minus 2. All right. Then we looked at solving trinomials. These are equations with 3 terms. So that's where we have the ax squared plus bx plus c equals 0. Now, there were 3 methods we had there. 3 methods there. The first method was factoring. Here we took the trinomial quadratic equation and broke it down to 2 binomials. So we'll call it a1 x plus answer 2. So we broke it down from quadratic to linear. Then we took both of these equations here and set them equal to 0. That's what we first looked at with a is 1. But then we had a is greater than 1. For example, let me see what we did. Make one up here. If we had 15x squared minus or plus 11x minus 8. Now let's make it 14. This method, we took the first term, put it in the first spot. Looked at the second sign. Remember, if the second sign is odd, the only way you have 2 terms multiply to be odd is if they're opposite signs. Then we took the first term and the last term, 15 times 8, and multiply them together. Equals 120. Then we have to look at what 2 terms multiplied together equal 120 when we do the second sign, which is subtraction. When we subtract them, we get 14. So it's first breakdown. What are all the possible combinations that multiply to equal 120? We have 120 times 1, 60 times 2, 40 times 3, 4 goes in there, 30 times 4. 24 times 5. 20 times 6. 15 times 8. And 12 times 10. Those are all the possible combinations I could think of. Now, when we subtract them, 120 minus 1 is 119. We need to get 14. Nope, that doesn't work. 60 minus 2 is 58. Nope. 40 minus 3 is 37. No. 30 minus 4 is 26. Nope. 24 minus 5 is 19. Getting closer. 20 minus 6 is 14. Those are them. Those are the numbers. 15 minus 8 is 7 and 2. So we know the numbers are 20 and 6. So the bigger number gets the positive 20 and 6. Then the next step was factor both of these out. What do they both have in common? They both have a 5. 5 goes into 15. So if we divide each of these by 5 in the first parenthesis, 15 divided by 5 is 3x. 20 divided by 5 is 4. The next one, they both have a 3 in common. Divide by 3. 15 divided by 3 is 5x. 6 divided by 3 is 2. They can't go, 3 is a prime number, can't go any further, doesn't go into 4. And so that's as far as it goes. Now, whatever we took out, we remove. What we're left with is the factor. So we set them both equal to 0. Set them both equal to 0. And solve. So x is equal to opposite sign of that one, divide by that. Opposite sign of that one, divide by that. So there. So that's the factoring method with a is greater than 1.
Mister,
Yes.
I have a question. How do you got the 5 where you divide it and the 3 when you divide it?
Here? Okay. That's a good question. So what's 15 made up of? 15 is made up of 3 times 5. And 20 is made up of what? 4 times 5. They both have a 5 in common, so I took out a 5. If I take out a 5, whatever you factor out here, to figure out what goes in here, divide both terms by what you factored out. 15 divided by 5 gives you 3. 20 divided by 5 gives you 4. Because you have to test your work. If I multiply these together, I have to equal that. 5 times 3, 15. 5 times 4 is 20. Same thing here. 15 is made up of 3 times 5. 6 is made up of 3 times 2. They both have a 3 in common. So take out a 3. To determine what goes inside there, I divide both of these numbers by 3. 15 divided by 3 is 5. 6 divided by 3 is 2. So I look for each one of these separately and see what they have in common. Whatever I have in common, I divided each of those terms separately, and I got the remainder. And that's what we have. Did that answer your question?
Yes.
Okay.
Thank you.
Thank you. Thank you. Okay, so that was the first method of factoring. The next method that we talked about was complete the square. The reason we use complete the square is because there may be instances where we can't factor. We can't factor this one, x and x. They're both positive. They're both the same. They're both positive. What times what is 10? When you add them, you get 6. So they're 10 times 1 or 5 times 2. If you add them, you don't equal 6. So we can't factor that one. So we have to complete the square. And that's an entire process. The first step. Move the C term. This is where we have x's on one side and non-x's on the other. So remove the C term. Oops, this is 6. So what we have now -10. So x squared plus 6x equals -10. Second step. Add b over 2 squared to both sides. Remember, the quadratic equation has this form. The b is whatever's in front of the x. So I say b over 2 squared, whatever's in front of the x is the 6. So I add 6 over 2 squared to both sides. Step 3 was 2 parts. The left side only do inside the parentheses. So on the left side, we only do this part. 6 divided by 2 is 3 squared. Because we want 2 terms under the squares. We need those. The right side, work it out. So we know 6 divided by 2 is 3. 3 squared is 9. So negative 10 plus 9 is negative 1. You have to get down to one number. So once we have 3 parts on one side and one number on the other side, on the left side, we have ax, so we have x squared term. Whatever is under the squares goes inside the parentheses. And whatever the first sign is goes between them and squared. So anything under the squared, that's for the squares. X and 3. And whatever the first sign is, just bring that down. Because now, once we have it in this form, we can put it in vertex form. By setting it equals 0. So add whatever that is to one side. So put everything on one side. And important, if you, at the first step, or at the first part, if you divided anything, we're supposed to have a is supposed to equal 1. So if we had a number in front here and we divided everything, at this point, whatever we divided out, we put back. So we'll have a, whatever that equation is. The vertex is whatever's inside there and whatever is outside, in this case. That's if you want the vertex form. But if you want to solve it, which is what the 5th step is, if you want to solve it, we try to get the x so that the square root both sides, the square and square root cancel, equals. Remember, whenever you square root a squared term, you have to put a plus or minus in front of the answer. The square root of -1 is I. And then subtract 3. X equals -3 plus or minus I. And there's your solution. Your answers are x equals -3 plus I and -3 minus I. This is the way that you have to answer it in the computer. That's called complete the square method. And it works no matter what. Let me show you with, this may be a little bit confusing, but it'll work out in the end. we have ax squared plus bx plus c equals 0. It's a quadratic equation. We use complete the square method on this one. First step. Remember, a has to equal 1. So in this case, we divide by a across the board. Each term gets divided by a. This is the reason I'm putting it on one sheet by itself. If you just you have an equation, a, b, and c, just plug them in there, and it'll work out the same way. Step 2, move the c term so b over ax. I move this term to the other side. So when I do that, I just change the sign. What I'm actually doing, I'm subtracting b over a to both sides. Third step. Add b over 2 squared to both sides. Remember, b is whatever's in front of the x. That is your b term. It's b is whatever's in front of the x. In this case, what's in front of the x is b over a. So at this step, we have b over a divided by 2. Negative c over a, b over a divided by 2. Fourth step. Well, let's first clean this up. The left side only inside the parentheses. So let's clean that up. X squared plus b over ax. The rule here is if you have, do it this way, b over a over 2. 2 is a fraction, so it's 2 over 1. Whenever you have a fraction over a fraction, take the top fraction, leave it alone. Take the top fraction, leave it alone. Multiply by the flip of the bottom. So if it's 2 over 1, I multiply by 1 over 2. If it's 3 over 5, multiply by 5 over 3. And then multiply. B times 1 is b. A times 2 is 2a. So this becomes b over 2a squared. Negative c over a plus b over 2a squared. All right. On the left side, we did the inside. Now the right-hand side, we have to simplify this equation. On the left side, we have x squared BA over AX B over 2A squared. So on this left side, we have negative C over A plus, since this is squared, we square each of these separately. So distribute, this 2 goes to everything inside there. So it's B squared, 2 squared, A squared. Two squared is 4. Now to add these two, we have to have a common denominator. This one has 4 and 2 A's. This one only has 1 A. So here we have to multiply top and bottom by 4A. 4A times A is 4A squared. 4A times C is 4AC, negative. Plus B squared over 4A squared. Okay, now we have a common denominator, so we just put it over the same denominator. So we have negative 4AC plus B squared. Now we have, that's one number. And left side, this. We're almost done. Whatever's under the squares goes inside the parenthesis. Whatever the first sign is goes there. So we have x plus b over 2a equals negative 4ac plus b squared over a squared. Now we're trying to solve for x. We have one number on this side, because if I had a, b, and c, just plug them in there and I get a number. So I have to square root both sides. Okay. I have to square root both sides. The square root and the square cancel. This has become a plus or minus because we square rooted that side. I'll put this on top and bottom separately. So we have, should put it closer, x plus b over 2a equals plus or minus, I'm writing this on this next page, negative 4ac plus b squared over square root of 4a squared. Okay, let's simplify this now. On the bottom, This equation can be, you solve it this way: square root of 4, square root of a squared. Square root of 4 is 2. Square root of a squared is a, which is good because now we have a common denominator. And the signs go to the top. This is a squared term, so we can move those around commutative property. So that was negative. I don't like negatives being first. All right, so now we get rid of this, but we get solve for x. Subtract b over 2a both sides. Since we have a common denominator, b squared minus 4ac equals x. And then we solve for x. That's a shortcut. And now we have a shortcut. Because remember, if we have a quadratic equation, once we identify what a, b, and c are, the values, we just have to plug those in there. Notice inside this equation, there's no x's. This is called the quadratic formula. This is our third method. This method always works. As you can see, it's a lot less cumbersome, has less moving parts. I'll show you when we look at. So this is the third part, the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac over 2a. So those are some of the examples we did last time. So we had x squared plus 5x plus 6 equals 0. Yeah, we could solve this by factoring. X, the same sign, they're both the same, they're both pluses. What times what is 6? When you add them, you get 5, 2, and 3. So we know the answers have to be -2, -3, the opposite signs. But let's go ahead and use the quadratic formula. So the first step, set the equation is set equals 0. It has to be in standard form. Label A, B, C. A is whatever is in front of the x squared, which is 1. B is whatever is in front of the x, which is a positive 5. And C is the constant, which is 6. The signs go with the numbers. If it's a -5, -5. If it's a -6, it's -6. Oops, 6, not a C. Plug the values inside the formula and solve. So -b. So it's -5 plus or minus b squared, which is 5 squared, 4 times a, which is 1, times c, which is 6, all over 2a, which is 2 times 1. Order of operations is we have to do inside the parentheses first. Now the radical. So 5 squared is 25. 4 times 1 is 4, times 6 is 24. 2 times 1 is 2. (25 minus 24 is 1. Square root of 1 is 1. So this gives us our two answers. -5 plus 1 over 2. -5 minus 1 over 2. -5 plus 1 is -4 over 2. -5 minus 1 is -6 over 2. -4 over 2 is -2, which is what we said. -6 over 2 is -3, is what we said. So this method here, using complete the square, the quadratic formula, requires really no thought. It's just plug and play. Look at the next one we had. First step, it is set equals 0. Second step, label A, B, and C. A is 1. B is 6. The sign goes with it. And C is 10. (b plus minus b squared minus 4ac over 2a. Always start off by writing the formula down. The more you write it, the easier it'll be to remember. So b is 6, so it's -6. B is 6, so it's 6 squared. 4 times 1 times 10 over 2. A is 1, 2 times 1. So -6. 6 squared is 36. Minus 4 times 1 is 4, times 10 is 40 over 2. -6. I can't do anything with the 2 until I finish the top. 36 minus 40. 40 is bigger, so it's negative. 40 minus 36 is 4. Square root of negative 4. There's a negative in there, so it's an I. Square root of 4 is 2. Now, do this next part. You can only divide by 2. Both of these terms have something in common. They both have a 2. So we factor out a negative 2. Because we don't like having negatives as the first term. So the negative comes out. So 2 goes into 6 3 times. Since this is plus or minus, it doesn't matter there. Take out the 2, so it's just I. So we have negative 3 plus minus I. Becomes negative 3 plus minus I. That's what x equals. Negative 3 plus I, negative 3 minus I. There's your answer. See, it works no matter what. Now it's the last one with that 15. Where's that? There it is. Okay. Label A, B, and C. A is 15. B is 14, positive 14. And C is negative 8. Now, since I'm solving, I use the quadratic formula. And just plug them in. Okay, here's a very important point. You notice we're solving for x. We're always solving whatever this middle term is. That's what we're solving for. It makes up everything. This x makes up both of those. This 14 makes up that. So b is negative 14, because there's a negative. I put a b as 14, so it's negative 14. 14 squared. A is 15. C is negative 8. 2 times A is 15. So negative 14. 14 squared is 14 times 14. 4 times 4 is 16. Carry the 1. 4, 56. It's 196. A negative and a negative becomes a positive. 4 times 15 4 times 5 is 20. 4, that's 60. So 60 times 8, 480. And 2 times 15 is 30. So these are both positive, so I add them. 480 plus 196, 676, the square root. All right, for time purposes, I'm going to use a calculator here. Let me see. So the square root of 676 equals 26. So it's negative 14 plus or minus 26 over 30. So we have negative 14 plus 26 over 30, negative 14 minus 26 over 30. Because we have to take one for each side. This is the plus side, this is the minus side, or however side you want to. 26 minus 14 is 12. They're both negative, so we add them. 26 plus 14 is 40. And simplify. They both have a 6 in common. 6 goes into 12 twice. 6 goes into 30 5 times. So 2 over 5. Answer is going to be negative, so only one negative. So they both have a 10 in common. 4 over 3. Those are your two answers. So x is equal to 2 over 5, comma 4 over 3. So again, the quadratic formula method requires the less thinking. Once you have your equation, plug in the coefficients, the numbers, and it works itself out. Now, the quadratic formula also does a little bit more than that. It does a little bit more than that. Remember, when you have a quadratic equation, just looking at it, we can tell a couple of things. By looking at the C, this is the y-intercept. This tells us the graph is a parabola. It either opens up or opens down. A tells us which one of these it is. If A is positive, it opens up. If A is negative, it opens down. If A is greater than 1, it's skinny. if A is between 0 and 1, the graph is wider. This 2 tells us at most 2 solutions, since we have 2 solutions, we're going to have one vertex. The vertex, so if you ever have x to the n, that's your biggest exponent. N tells us number of solutions, n minus 1, the number of vertices. So we pretty much know the basic shape of this graph. We know it's a parabola. If that's positive, it opens up. If it's negative, it opens down. We know where it crosses. Now, this equation tells us the x-intercepts. This is our solution, the x-intercepts. So now we have the y-intercept, we have the x-intercepts, but it tells us a bit more. This equation part right here, this part inside here, is called the discriminant. The discriminant tells us the number of real solutions. Remember, a quadratic equation can have one of 3 possibilities. We can have 2 solutions, 2 real solutions. We have 1 real solution. Or we have no real solutions. Because if you're going to have no real solutions, there's no need to do this. Because remember, your solutions are the x-intercepts. So if you're going to have no real solutions, you don't have to worry about doing the factoring or the quadratic equation. You're done. So here's what this discriminant tells us. The discriminant is the b squared minus 4ac. That's the part of the discriminant. It will tell us these things. This is how. If b squared minus 4ac is greater than 0, if it's positive, then we have 2 solutions. What does that mean? Well, in a quadratic equation, if this part is a positive number, if it's greater than 0, let's say like 4, then we'll have the plus or minus of whatever that is. So it'll be 2 answers. So if this is a positive number, then we can take a square root of it. And we'll have 2 answers. If b squared minus 4ac is equal to 0, then we have only one solution. So if b squared minus 4ac equals to 0, that the whole thing is 0. So it's negative b plus or minus 0. We only have one x-intercept. So we have one solution. So x is equal to negative b over 2a. We only have one solution. If b squared minus 4ac is less than 0, means negative, then we have no real solutions. So if inside here, the discriminant, if it's negative, it's less than 0, square root of a negative number is imaginary. Once it's imaginary, we don't have a real solution anymore. If b squared minus 4ac, if you work that out and you get a negative number, you don't have to do the x-intercept, the quadratic formula, because it's going to be imaginary. The only way, if you just ask to, okay, what would the value be? In other words, this kind of graph would look like this. This kind of graph would look like this. And this kind of graph would look like this. When it comes to graphing, you wouldn't have to do that. If you're asked to find the x-intercept, so solve it, then you have to tell me, okay, work it out, tell me it's imaginary. But when it comes to graphing, you're done. All right, so that's the discriminant. So see, each part of this, the equation, the quadratic equation, we're looking at it and we're determining more about the equation. Quadratic in form. You will always have an equation that's going to look like ax squared plus bx plus c. That's quadratic. A quadratic in form could be something like this. Or each of these equations, and there's a certain pattern that we're looking at here. Each of these equations are what we call quadratic in form. You notice, again, when we use the quadratic formula, we're solving for this one. It's x. So as long as you have this, if the first exponent is 2 times the second, so if this is 1, 1 times 2 is 2, then it's quadratic. 2 times 2 is 4. 4 times 2 is 8. 10 times 2 is 20. That means these are all quadratic in form. Let me give you an example. Okay, x to the 4th minus 5x squared plus 4 equals 0. It is not quadratic, but first off, it's a trinomial. Because quadratic equations are trinomials. Good point. So that's the first thing you have to look at. We know they have to be trinomials, or we learned earlier it could be binomials. The first term has to be, the first term has to be 2 times the middle term. 2 times 2 is 4. So this equation is quadratic in form, which means we can solve it the same way we've been doing in the past. This 4 means we're going to have 4 answers. At most 4. The way you do this, whatever this middle term is, let's say y equals x squared. The middle term is pretty important. That's what you're solving for. So y equals x squared. Now, using this, I can rewrite the equation. What is x to the 4th? If x to the 4th is x squared squared. So it means I have to square y. So y squared is the same thing as x to the 4th. So this equation, it looks like y squared, because y squared is actually x to the 4th. So that's that. I'm just changing the way it looks. What is x squared? X squared is y. Now this looks familiar. we can solve this one. If you factor, then you have y, y. The second sign's a plus, so the same signs. They're both minus. What times what is 4? When you add them, you get 5. 4 times 1 is 4. 4 plus 1 is 5. So it's 4 and 1. So now we take both of these equations, set them equal to 0, and solve. So y is equal to 4, and y equals 1. But remember, y is equal to x squared. We start off with x's, we have to end with x's. So this is x squared equals 4. X squared equals 1, because y equals x squared. We have to replace it. So I square root both sides. X equals plus or minus 2. X equals plus or minus 1. Those are my 4 answers. X equals -1, +1, -2, +2. So that's how quadratic inform works. You just have to rewrite it in something else. That's my process of substitution. I'm substituting anywhere I see an x squared, I'll just put a y. So that's 5y. This is 5y squared. You can also solve this using the quadratic formula. But remember earlier I said, when you do the quadratic formula, what you're solving for is the middle term. The middle term now is x squared. So a is 1, b is -5, and c is 4. So there's the negative. B is -5. Plus minus -5 squared. 4 times 1 times 4. 2 times 1. Negative and negative is a positive. -5 squared is 25. 4 times 1 is 4. Times 4 is 16. Over 2. 5 plus or minus 25 minus 16 is 9. square root of 9 is 3. So we have 5 plus 3 over 2. 5 minus 3 over 2. So 5 plus 3 is 8 over 2 is 4. 5 minus 3 is 2. 2 over 2 is 1. Remember, they equal x squared. So x squared equals 4. X squared equals 1. Square root both sides. X equals plus or minus 2. X equals plus or minus 1. Those are your 4 answers. X equals -1, +1, -2, +2. Because we have to have 4 answers. (20 times 6). Manuel, what do you mean by 20 times 6? I just not saw you had a chat. Yeah, 20 times 6 is 120, right? Earlier. Okay, well, that does it for section 2. And from here on out, now that we went through the processes, now we can start using these rules and formulas when we start solving all these things. The next section we're going to talk about on Monday is analyzing graphs of quadratic equations, and we'll look at rational and radical equations. All right, so let me end this recording and we'll start again looking at the solutions.